In section 5.3, we're going to go the other way and start with fractions and turn them into decimals. So in section 5.1, we started with decimals and we turned them into fractions. Now we're going to go the opposite way. So we're going to start with some fractions, turn them into decimals, and see if we can figure this out together. So since we know that our place values for decimals are tenths, hundredths, and thousandths, wouldn't it make sense if we could get our denominator to equal a 10, 100, or 1,000? That would make sense because then we can just go ahead and turn that numerator into the decimal value in that placeholder. So that's the the concept that we kind of want to get used to when we're starting with a fraction and turning it into a decimal. And we're going to do that in just a moment. But I also want to share with you that every fraction is a division problem. So I know I've mentioned this before. So in the real world, you're not going to be doing this by hand and by head. You're going to pull out your phone or your calculator and you're going to do it on your calculator. So every fraction, if you want to turn this into a decimal, the easiest way to do that is with your calculator. And just do 4 divided by 5 on your calculator, 13 divided by 20, or 17 divided by 4. So each of these are just division problems with your top being your dividend and your bottom being your divisor. And you can do that on your calculator very easily. So the reason why I'm telling you that is so that when you do this by hand, you can use your calculator to check your answers. All right, so our first one is 4 over 5, or 4/5. Can we get this bottom number to equal a 10, 100, or 1,000? Well, we can get it to equal all of them, but let's use the smallest one. We can get it to equal a 10. So we're going to go ahead and turn this into a 10. And we turned it into a 10 by multiplying by 2. So in chapter 4, we learned that for fractions, to keep them equivalent, whatever we do to the bottom, we do to the top. So 5 times 2 equals 10. So 4 times 2 equals 8. So now we have 8 tenths, and tenths is a decimal place. So tenths is our first decimal place behind the decimal. And what are we going to put in the tenths place? We're going to put an 8 there. Our next one is 13 over 20. Can we get 20 to equal 10, 100, or 1,000? And again, we could get it to equal all 3 of them, but the one that makes the most sense is going to be equaling 100 because we can use a whole number to get there. So if we want our 100 to be our new denominator, what did we do to the 20 to get it to equal the 100? We multiplied by 5. So 20 times 5 equals 100. Whatever we do to the bottom, we do to the top. And 13 times 5 equals 65. So now we have 65 hundredths. So again, hundredths is a place value, and it's our second place value over. So we would read it as 65 hundredths because we're using up to the hundredths place value, so our tenths and our hundredths. So we would write it like that, or you could put that 0 out front. Either way is fine. So again, we're just trying to get our bottom number, our denominator, to equal a 10, 100, or 1,000, because if we can get it to equal that, that is one of the place values, tenths, hundredths, or thousandths. Now our last one is a little bit different because it's an improper fraction. So when we're dealing with decimals, an improper fraction just means that we're going to have a number to the left of the decimal, so where the whole number is supposed to go. So in this case, it would actually make more sense to take this improper fraction and turn it into a mixed number. So in chapter 4, I did have a couple homework problems doing that, and this is why, because there is a specific situation where that might come in handy, and this is one of them. So when you have an improper fraction and you're trying to take that fraction and turn it into a decimal, go ahead and just make it a mixed number, because then you know what the whole number is going to be for your decimal. So 4 goes into 17. 4 goes into 17 how many times? 4 times, because 4 times 4 is 16. So we know that this is going to become a big number 4, and from 16 to 17, there's just 1 left over. And the 4 never changes. The denominator never changes when you're converting back and forth between mixed numbers and improper fractions. And so just to check our work, we can take this bottom and multiply it by the whole number. 4 times 4 is 16. And then 16 plus 1, we add the numerator, equals 17. So now we have 4 and 1/4. This 4 is going to become the whole number that's to the left of our decimal. Okay? So 4 point. The fraction is what's going to equal what's behind the decimal or to the right of it. So can we get this number to equal a 10 or 100 or 1,000 evenly? Well, we can get it to equal 100 evenly if we multiply by 25, right? So we can take this and multiply by 25 on the top and the bottom. And our new fraction is just going to equal 25 over 100. So 1/4 in decimal format is going to be 0.25, which makes sense because when we're talking about money, $1 is 100 cents and $0.25 is 25 cents. So 4.25 would be the decimal equivalent of 4 1/4, or 17 over 4. So this is the only one where you kind of want to think back to chapter 4 and a couple of those problems that we did together is when you're dealing with an improper fraction, go ahead and turn that into a mixed number before you turn it into a decimal because it'll make it just a little bit easier. It'll organize your numbers a little bit better.